So welcome to this revision video on pneumatic systems. This is the last video in our AQA engineering systems. And again, thank you to Paul Braden for the revision material that he put together. What I've done is I've kind of used this as a base to create some answers to questions that might help you when you're revising. So what you can see here, some of the things that we are going to discuss are the differences between pneumatic and hydraulic systems. And here are some of the key things that you will learn about how there are compressed air chambers used in pneumatic systems and the forces that are applied. So we'll talk a little bit about the formula, such as pressure equals force divided by area, and we will also talk about some of the tools that you can use as a result of this in some of these questions. So let's have a look at our first question here. It says, describe the difference between a pneumatic and a hydraulic system. The other thing we say is describe how single and double acting cylinders work. So what I'd like you to do at this point is pause this video and then go over your answer and check it to see how close you were to the answer. So there are two types of systems. We have our pneumatic system and our hydraulic system. There are two main types of system, and with this in mind, you need to be able to describe both of them in the different situations where you might use them. Now, hydraulic systems use a liquid such as water or oil to give the pressure, whereas pneumatic systems use compressible air or gas. Now, when you're answering these questions, you really need to think about the speed and power and the environment that you're in. Now, the great thing about pneumatic systems is they are much faster to operate. Air compression is much faster and it applies the force in one area. Air can be put straight into the atmosphere with hydraulics. Pneumatic systems, however, are a lot cleaner and require less maintenance because they don't use oil or liquids in the surrounding environment. So you need to just be able to compare the difference here. So where hydraulic systems will use water or oil, pneumatic systems use compressible air, which are a lot easier to maintain and produce less fluids to the environment. Now, the other thing you need to be able to describe is how single and acting cylinders work. Single acting cylinders use pneumatic pressure to create a force or linear motion. This will be done in one direction only. The force is usually projected out of the component itself, and a spring helps to move it into that position. So the force is a single acting force of air, if you like. The downside of this is that sometimes the spring can result in more force than you actually need, depending on how strong that spring is, I guess. Double acting cylinders can also extend and retract with pneumatic pressure. It uses two ports, one for bringing in the air from outwards and one for the inward motion. And the way that we can calculate the force is equal to pressure times area. So this question here asks you how the pneumatic AND circuit works. Okay, so it's talking about the AND gate. And then the next question says, how do you achieve a delay circuit? So I want you to pause the video at this point, see what you can do, write down your answer, and then resume. Now, here is an example of an AND circuit using pneumatics. So what happens is valves are placed in a series or a parallel circuit to create these logic circuits. Now what happens is with an AND circuit you have two valves. Now in order for this circuit to work, the two valves connected must both be pressed in order for the cylinder, which is the bit on the right, to operate. So you think back to how we did logic gates. Both of these valves need to be pressed in order for the cylinder to operate. Now with an OR gate, it would only need to be that one of those valves is pressed in order for the circuit to activate and for the cylinder to operate. So just bear that in mind. Now a delay circuit is created by using a unidirectional flow control valve. Now what happens with this is that there is a reservoir connected in the series. The valve is then used to restrict the flow of air into the reservoir. The reservoir controls the time delay. So what's happening is this reservoir is filling up slowly, and depending on how quick that fills up will just depend on how quick the circuit is activated. So the delay can be increased or decreased using the adjustable control valve. The 5-port valve is operated when the pressure in the reservoir is such as at the required level. When the air is released into the piston cylinder, it will move. So when the air is released into that piston cylinder, it will move. So this is our last question in this series, and it asks what type of motion are created in a single and double acting circuit. So you'll need to pause at this point, but I'll also go over some of the applications and where you might use some of this. So to finish this off, a single acting cylinder will create a motion in a single direction only. This is a recap from another question. So this motion is linear and usually in an outward force, whereas double acting cylinders can create motion in an outward and inward motion. So single acting cylinders will produce the outward motion, such as forcing it out, whereas a double will take an inward and outward motion. Now, where you might use pneumatics is in many situations. You may use it for the benefit of it being fast, so it has high speed. It has accuracy and precision. They're often used in production lines to increase automation. So assembly tools can be powered and controlled. It also reduces the amount of human labor needed. Now, you may argue that people are losing their jobs for this reason, but that could be an ethical consideration that you could have in an extended answer. But the good thing is that they increase the speed and accuracy in production. Now, the type of tools that you usually get that are pneumatic might be something like a jackhammer, a drill, a saw, a screwdriver. I mean, you may see pneumatic tools used in the Formula One racing when they are trying to tighten those wheels in a super fast speed. So all of these things need to be considered in your answers, but always think about the scenario you've been given and how that applies. Whenever you need high speed accuracy or precision, you're really going to go down the route of pneumatics. Remember that with hydraulics, you do have the risk of working with fluids and working with oils. So there is going to be an element of maintenance to consider there.